Hello everyone, and welcome back to the channel. In this tutorial, we're going to rig a fully functional excavator in Blender, step by step, in a way that's simple and easy to follow. So if you've ever wanted to understand how mechanical rigs work and build one from scratch, you're in the right place. Let's get started. First things first, in the scene, I already have a simple excavator model that I created earlier. I'll share the download link in the description. This mechanism is built from 5 main parts. We have the boom, which is the main arm that lifts the structure up and down. Then we have the arm, which extends the reach of the excavator. Next is the bucket, the part that actually digs and carries material. We also have the linkage mechanism, which connects the bucket to the arm and transfers the motion. And finally, the most important part, the piston system that controls the boom, arm, and bucket. Each piston is made of 2 parts, the piston base and the piston rod. First things first, press A to select the entire mechanism. Then, press Ctrl A and apply rotation and scale. This step is important because it resets all transforms and makes sure everything behaves correctly when we start rigging. It's very important that each part of the mechanism rotates exactly around its pivot point. We'll keep this in mind throughout the rigging process. Now let's start with the boom. Select it, then press numpad/ to isolate it in the scene. The boom should rotate from this hinge point at the bottom, so we need to place the bone there. Press Tab to go into edit mode, then press 3 to switch to face select mode. Hold Alt and click to select this face loop. Now press Shift S and choose Cursor to Selected. This will move the 3D cursor exactly to the center of the selected faces. Once that's done, we're ready to put the first bone there. Now press Tab to go back to object mode. Then press Shift A, go to Armature, and add a single bone. To see the bone clearly inside the model, go to the Armature Properties panel. Open the Viewport Display section and enable In Front. This will make the bone visible through the mesh, so it's much easier to work with. As you can see, the bone has 2 tip points, head and tail. If you press R to rotate it, notice that the bone rotates around the head, which acts as the pivot point. Now we need to move the tail of the bone to the upper hinge where the boom connects to the arm. So, select the boom again and go into edit mode. You can see that this upper hinge is made of 2 sides. First, select the face loop on one side. Then hold Shift Alt and select the face loop on the other side as well. Now press Shift S and move the 3D cursor to the selection. You'll see that the 3D cursor is placed exactly at the center point between the selected face loops. Now go back to object mode, select the bone, and enter edit mode again. Select the tail of the bone, then press Shift S and choose Selection to Cursor. This will snap the tail of the bone exactly to the 3D cursor position. Now press F2 and rename the bone to Boom. Then press numpad/ to bring back the full mechanism. Alright, now let's create the bone for the arm. Press numpad 3 to switch to the side view. While still in edit mode and with the tail of the bone selected, press E to extrude a new bone. This new bone will be used for the arm. Now we need to snap the tail of this bone to the bucket's pivot point where the arm connects to the bucket. To do this, go to object mode, select the arm, and isolate it in the viewport. Enter edit mode, then select the inner face of this lower hinge. Press Shift S and move the 3D cursor to the selection. After that, go back to object mode, select the armature, and enter edit mode again. Select the tail of the bone, press Shift S, and choose Selection to Cursor. This will snap the tail exactly to the correct pivot position. Now press F2 and rename this bone to Arm. Now let's continue the same way. While still in edit mode, press E to extrude another bone. We'll move the tail of this bone to the hinge point where the linkage connects to the bucket. Use the same method as before to place the 3D cursor at that pivot, then snap the tail to it. Once that's done, press F2 and rename this bone to Bucket. Now the main chain is complete. Now let's connect the bones to the mechanism and test if everything works correctly. First, go to Object Mode, select the boom, then hold Shift and select the armature. Now switch to Pose Mode and select the bone that will control the boom. Press Ctrl P and parent the boom to this bone. Now let's do the same for the arm. Go to Object Mode, select the arm, then hold Shift and select the armature. Switch to Pose Mode and select the arm bone. Press Ctrl P and set this bone as the parent of the arm. Finally, let's do the same for the bucket. Set the bucket bone as the parent of the bucket. Now the full chain is connected and ready to test. With the bucket bone selected, press R, then press X twice to rotate it along its local X-axis. If the bucket rotates exactly around its pivot point, that's perfect. Now select the arm bone and rotate it the same way, along the local X-axis. As you can see, the arm rotates from its pivot point and the bucket follows along. That's because the bucket bone is a child of the arm bone in the hierarchy. Finally, test the boom bone as well. As you can see, everything is working correctly. While working on this excavator rig, I realized something. Rigging is just one part of the process. Even if your rig is perfect, without good animation, it won't really feel alive. So I decided to improve my animation fundamentals, and I found a really helpful class on Skillshare about character animation in Blender. What I liked about this course is that it focuses on the core principles like timing, spacing, and squash and stretch. And instead of just theory, you actually practice everything step by step. For example, I finally understood how small timing changes can completely change how an animation feels, which is something I didn't fully get before. And honestly, it gave me a much better understanding of how to bring my projects to life. If you want to improve your Blender skills like this, the first 500 people who click the link in the description or scan the QR code on screen will get a 1-month free trial of Skillshare. And once you join, you'll also get access to hundreds of other Blender courses on the platform, so definitely check it out. Alright, now let's move on to the pistons. This is the most important part of the rig. Each piston has two parts, the base and the rod. As the mechanism moves, the rod slides in and out of the base, extending and compressing between the pivot points. First, let's create the piston that controls the opening and closing of the arm. This piston will drive the main movement of the arm. Go to Object Mode, select the piston rod, and press numpad/ to isolate it. Enter Edit Mode and select the face loop where the piston rod connects to the arm. Press Shift S and move the 3D cursor to the center. This will be the pivot point of the piston rod. Now go back to Object Mode, select the armature, and enter Edit Mode again. Press Shift A and a new bone will be added exactly at the 3D cursor position. Now we need to align this bone with the piston rod. Go to Object Mode, select the piston rod, and isolate it again. Enter Edit Mode and select the face at the very end of the rod. Press Shift S and move the 3D cursor to this point. Now go back to Object Mode, select the armature, and enter Edit Mode. Select the tail of the bone, press Shift S, and snap it to the 3D cursor. Now the bone is perfectly aligned with the piston rod. The bone looks a bit too long. Select the bone, press N to open the side panel, and reduce the length value to make it shorter. Once you're happy with the result, press F2 and rename the bone to Arm Piston Rod. Alright, now let's do the same for the piston base. Go to Object Mode, select the piston base, and isolate it. Place the 3D cursor at its pivot point. Then go back to Object Mode, select the armature, and enter Edit Mode. Press Shift A to add a new bone at the 3D cursor. Now move the 3D cursor to the center of the piston base and align the bone with it, just like we did before. Adjust the length value to make the bone shorter if needed. Once you're happy with the result, press F2 and rename the bone to Arm Piston Base. Now let's connect the bones to the piston. Go to Object Mode, select the piston rod, then hold Shift and select the armature. Switch to Pose Mode and select the Arm Piston Rod bone. Press Ctrl P and set this bone as the parent of the piston rod. Now the rod will follow the bone correctly. Now let's do the same for the piston base. Go to Object Mode, select the piston base, then hold Shift and select the armature. Switch to Pose Mode and select the Arm Piston Base bone. Press Ctrl P and set this bone as the parent of the piston base. Now both parts of the piston are connected properly. Now, select the arm bone and rotate it. As you can see, the piston rod bone stays in place because it's not connected to the arm bone yet. Now go into Edit mode. First, select the arm piston rod bone, then hold Shift and select the arm bone. Press Ctrl P and choose Keep Offset to parent the piston rod bone to the arm bone. Now go back to Pose mode and rotate the arm bone again. You'll see that the piston rod bone now moves together with the arm, which is good. But during this motion, we want the rod to slide inside the piston base, extending and compressing as the arm moves. To achieve this, we'll add a damped track constraint, so the piston rod bone always points toward the piston base bone. Now let's set that up. In Pose mode, select the arm piston rod bone and go to the Bone Constraints tab. Add a damped track constraint. For the target, use the eyedropper and select the armature, then choose the arm piston base bone as the target. Set the tracking axis to the bone's local positive y-axis. Now do the same for the arm piston base bone. Add another damped track constraint, and this time set the target to the arm piston rod bone. Now, when you select and move the arm bone again, you'll see that the piston rod slides inside the base, extending and compressing naturally. As you can see, the mechanism is working smoothly. However, if you select the boom bone and rotate it, you'll notice that the piston base bone can't follow and the mechanism breaks. To fix this, go into Edit mode. Select the arm piston base bone, then hold Shift and select the boom bone. Press Ctrl P and choose Keep Offset to parent the piston base bone to the boom bone. Now the system will stay connected and work correctly. If you want to reset the system back to its rest pose, press A to select all bones, then press Alt-R to clear the rotations. Now, you may notice that sometimes the piston setup breaks. This happens because of a dependency cycle caused by the damped track constraints. This is not something we want. To fix it, instead of making the piston base bone follow the piston rod bone directly, we'll add an empty object and use it as a stable target. Now let's fix this step by step. Go to Object mode, select the piston rod, and press Shift-S to move the 3D cursor to its pivot point. Press Shift-A and add an empty exactly at this position. Now hold Shift and select the arm, then parent the arm to the empty. This way, the empty will follow the arm's movement. Next, select the armature and switch to Pose mode. Select the arm piston base bone and go to the damped track constraint settings. Remove the old target and set the empty as the new target. Now test the system again by posing the arm. You'll see that the piston rod no longer breaks and the entire mechanism works smoothly. Alright, now let's move on to the piston that controls the bucket mechanism. This setup is a bit different because we have a linkage system between the piston and the bucket. Instead of driving the bucket directly, the piston moves the linkage, and the linkage transfers that motion to the bucket. Now let's set this up step by step. First things first, go into Edit mode and select the tail of the bucket bone. Press E to extrude a new bone. We'll move the tail of this new bone to the pivot point where the linkage connects to the piston system. Go to Object mode, select the lower linkage part, and isolate it. Enter Edit mode and place the 3D cursor exactly at the pivot point. Now go back to Object mode, select the armature, and enter Edit mode again. Select the tail of the new bone, then press Shift-S and snap it to the 3D cursor. Now the bone is perfectly positioned at the correct pivot. Now at this point, the armature will split into two branches. One branch will control the piston rod and the other will control the upper linkage. First, press E to extrude a new bone. Then move the tail of this bone to the pivot point of the upper linkage. Use the same method as before to position it accurately with the 3D cursor. Now let's create another bone for the piston rod. Press E to extrude a new bone and align it to the center of the piston rod. Use the same snapping method with the 3D cursor to place it accurately. Now press F2 and rename this bone to bucket piston rod. Now let's connect these 3 bones to the parts they are meant to control. We'll use the same parenting method as before to link each bone to its corresponding object. Now select the bucket bone and rotate it. As you can see, the upper linkage bone is not properly fixed to its pivot, so the motion doesn't behave the way we want. To fix this, we'll use an inverse kinematics constraint. Now select the upper linkage bone and go into Edit mode. Select the tail of the bone, then move the 3D cursor to that position. Go back to Object mode and add an empty exactly at this point. Now hold Shift and select the arm, then press Ctrl-P to parent the arm to the empty. This way, the empty will follow the arm's movement. Now select the armature again and switch to Pose mode. Select the upper linkage bone and add an inverse kinematics constraint. Set the target to the empty object we just created. Make sure to set the chain length to 2. This is important. Now select the bucket bone and rotate it again. As you can see, the linkage mechanism is now working correctly. Next, we'll add a damped track constraint to make the piston rod slide properly inside the piston base. Just like we did for the arm piston, we'll repeat the same setup here. Add a new bone at the pivot point of the piston base and align it exactly to the center of the base. Once that's done, press F2 and rename the bone to bucket piston base. Now let's connect the piston base to this bone. Go to Object mode, select the piston base, then hold Shift and select the armature. Switch to Pose mode, select the piston base bone and press Ctrl-P. Set this bone as the parent of the piston base. Now the base will follow the bone correctly. Go into Edit mode, select the piston base bone, then hold Shift and select the arm bone. Press Ctrl-P and choose Keep Offset to parent the piston base bone to the arm bone. Now select the piston rod bone and add a damped track constraint. Set the target to the piston base bone. Then select the piston base bone and add another damped track constraint. Just like before, we'll use an empty as the target to avoid dependency cycle issues. Now go into Edit mode and select the exact pivot point between the upper and lower linkage. Move the 3D cursor to this position. Add an empty at this point. Finally, parent the linkage to the empty, so the empty follows the linkage correctly. Now select the armature and switch to Pose mode. Select the base bone and in the damped track settings, set the target to the empty object we just created. Now go back to Pose mode and test the system by rotating the bucket and arm bones. Once you're happy with the result, you'll see that everything is working correctly. Finally, to make sure all the connection pins follow the system correctly, we need to parent them to their corresponding parts. Go through each pin and parent it to the part it belongs to. This way, all the small details will move together with the mechanism and stay perfectly in place. Now let's move on to rigging the boom pistons. Before we continue, let's make the bones easier to see in the viewport. Select the armature, go to the Armature Properties panel, and open the Viewport Display section. Change the bone display from octahedral to stick. This will give us a cleaner view of the mechanism while working. Now, select the piston base and isolate it. Move the 3D cursor to the pivot point where it connects to the boom. Then select the armature, go into Edit mode, and add a new bone. Align this bone to the center of the piston base. Press F2 and rename it to boompistonbase.r. Make sure to include the .r at the end because we'll mirror these bones to the other side later. Now let's do the same for the piston rod. Add a new bone and align it exactly to the center of the rod. Then rename it to boompistonrod.r. Now select both of the bones we just created. Open the armature menu and choose Symmetrize. This will mirror the bones to the other side automatically, and the new ones will have the .l suffix. Now move the 3D cursor exactly to the head of this bone, which is the pivot point. Then go to Object mode and add an empty at this position. Now hold Shift and select the piston base, then parent the empty to it. This way, the empty will follow the base correctly during the motion. Add the new empty object to the other side. Now let's parent each piston part to its corresponding bone. Go through them one by one and use the same method as before to connect each piston to the correct bone. Now, we'll add damped track constraints to these bones so the piston can slide properly inside the cylinder. First, select the piston base bone and add a damped track constraint. Set the target to the empty object. Then select the piston rod bone and add another damped track constraint. This time, set the target to the piston base bone. Now repeat the same steps for the piston bones on the right side. Now select the boom bone and rotate it along the x-axis. As you can see, the mechanism is not working yet. That's because the piston base bones are not connected to the boom bone. Now go into Edit mode. Hold Shift, select the piston base bones first, and then select the boom bone last. Press Ctrl P and choose Keep Offset to parent them to the boom. Now the system will follow the boom correctly. All right, now we're at the final step. We want the entire system to rotate together when the base rotates. Go to Object mode, select the base, and isolate it in the viewport. Enter Edit mode. Select the bottom circular face of the platform and press Shift-S to move the 3D cursor to its center. Now go back to Object mode. Select the armature and enter Edit mode. Press Shift-A to add a new bone at the exact center of the base. Press F2 and rename it to Base. Now select the boom bone first, then select the base bone. Press Ctrl P and choose Keep Offset to parent it. Now let's connect the platform to the base bone. Go to Object mode, select the platform, then hold Shift and select the armature. Switch to Pose mode and select the base bone. press Ctrl-P and set this bone as the parent of the platform. Now, rotate the base bone along its local Y-axis. As you can see, the entire mechanism now rotates together with the base. However, now you'll notice that the piston rods are not rotating with the platform. To fix this, we need to connect the piston bones to the base bone. Go into Edit mode, select the piston base bones one by one, and then select the base bone last. Press Ctrl-P and choose Keep Offset to parent them. Now when you test the system, you'll see that everything is working correctly. Let's limit the rotation of the boom, arm, and bucket bones. This is important because we don't want the piston rods to slide out of the cylinders. In Pose mode, select the boom bone and go to the Bone Constraints tab. Add a Limit Rotation constraint. Set the space to local space, since we want to limit the rotation in the bone's local axes. Enable the Y and Z axes. Now if you press R and try to rotate the bone, you'll see that it only rotates along the local X-axis. Next, let's limit the rotation on the X-axis as well. Press R and rotate the bone and watch the value at the top to see the angle. Enable the X-axis in the constraint and enter these values. We'll set the minimum to -20 degrees and the maximum to +20 degrees. Now when you rotate the boom bone, you'll see that it stays within the defined limits. Now do the same for the arm and bucket bones. Select each bone in Pose mode, add a Limit Rotation constraint, and set it to local space. Enable the Y and Z axes to lock them, then limit the rotation on the local X axis. Once that's done, both bones will rotate only within their defined ranges. Great! We've completed the entire excavator rig. I hope you found this tutorial helpful and easy to follow. If you enjoyed it, don't forget to like the video and subscribe to the channel for more Blender tutorials like this. Thanks for watching, and I'll see you in the next one.